Hi, Geometry. This is our proof practice worksheet. So if you can't print this, you can write this on your own sheet of paper. So this is going to support us in doing some of the proofs that we're finding in lessons 4 through 10 of our workbook. So when you get ready to start a proof, the very first thing you should do, your step 1, should always be to show the information in the diagram using tick marks or the congruent sides and arcs for congruent angles. This is the information that you and I are given. So whatever we're given, we should show that information in the diagram. So now step 2, we're going to show information that we know because we understand vertical angles are congruent, that shared sides are congruent by their reflexive property, or often with parallel lines, we need to mark 1, if not 2 sets of alternate interior angles. Finally, then, we look at our picture and we decide why our triangles are congruent. So far, we've been concentrating mostly on side, 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 angle, side, angle. But there's also angle, angle, side, and HL that we're going to be learning as reasons that 2 triangles might be congruent. And finally, we have to do any steps we need to do to complete the proof, such as sometimes we are not done when we prove the triangle is congruent. We have to do a step further, for example, when I use my CPCDC, which I'll show you in just a moment. So let's begin with number 1. So this is my given, and this is what I'd like to prove, and this is my diagram. So I first, step 1, mark the things that I'm given. So I'm given that side BC and DC are congruent. I'll mark them with the same number of tick marks. And I'm given that the side AC and EC are congruent. Again, I'll mark them with identifying tick marks. So now I'm ready for step 2. Is there anything else I know? Not it looks like it, but things that I know for a geometric fact. Well, one of those things that we've learned is that vertical angles are congruent. I have a vertical angle right here where my 2 triangles intersect at C. That angle is congruent in both of them. So now, step 3, I can visually see that my triangles are congruent by side, angle, side. So now I'm ready to complete my proof. So remember, I have to have a statements column, and then I have to have the reasons for all those statements. So my first statement is always my given. Since I have 2 pieces of given, you can write it as 1, 2 statements, or you can write them both in the first statement. I'm going to write them both in the first statement, but it's fine if you wanted to make a statement 1 and a statement 2 for each of those. And that would be the given. So 2. Once I marked those, the second thing I marked was my vertical angles. So now I'm going to write that my angle, and I can't say angle C, there's 2 angles at C. So I'm going to call this BCA. So angle BCA is congruent to angle. Now, very careful. Since I called this BCA, I have to call this one DCL. DCL. And is that DCL? I think that's an E. For some reason, my printer printed parts of this very lightly. Sorry about that. And that was vertical angles are congruent. Lots of abbreviations for me there. So now my 2 triangles are congruent by side, angle, side. I have 1, 2, 3 pieces of necessary specific information. So 3, my triangles are now congruent. Let's write them the same way they're written in the proof statement. So I'm going to write it as BCA congruent to triangle DCE, and that is because of side, angle, side. So if that's what I was supposed to prove, I would now be done. But this is also now where I've now proven all 6 parts, all 3 sides, all 3 corresponding angles are congruent. So this problem could be changed slightly. I'm going to cross this out. Maybe that wasn't what I was asked to prove. Maybe I was asked to prove that angle B is congruent to angle D. If that was the case, I wouldn't be done on the line where I say the triangles are congruent. So now my 2 triangles are congruent, and I would go one more step. to say that B was congruent to D, and that's because they're in a congruent triangle. They are corresponding parts, CP, of two congruent triangles, and so they are congruent. So let's look at number 2. So I'm going to begin with my step 1. I'm going to mark the given. So I need to mark JK and LK. So JK and LK. And then I need to mark JM and LM. So this is JM and this is LM. And now I'm to step 2. This is where I mark things that I know. Well, I have a shared side. This side, KM, is in both triangles. So I'm going to mark that congruent to itself by the reflexive property. It's pretty easy for me to see this one is congruent by side, side, side. So I'm now ready to write this up. So I remember I have my statements, and then I have my reasons why I'm allowed to say those statements. So my first statement is always my given, and I'm going to write it as one statement. So I'm going to write both of these in one, but you could write it as 2 separate statements with the reason being given for both of them. And that is the given. And so then the next thing I put on my diagram was that KM was congruent to KM. KM is congruent to KM, and I know that because of the reflexive property. So finally, I've proven my 2 triangles congruent. So my triangle, and I'm going to write it just like it is in the prove statement. This is always my last line, just what it says there. I don't have to think too hard about that part of it. So I know that by side, side, side. So this proof is now finished. However, once I prove my 2 triangles are congruent by side, 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 I know the other 3 pieces of information, which in this case happens to be my 3 angles, are congruent by CP/CTC. So I could change this proof and make it 1 step longer if instead of being asked that to prove the triangles were congruent, if instead I was asked to prove, let's do this angle right here, J and L. So we'll call it KJM, angle KJM, congruent to angle KLM, angle KLM. So if that's what I was asked to prove, it would be 1 more step after the triangles are congruent. I can now say any of the remaining parts of my triangle, corresponding parts of my triangle, are congruent by CP/CTC. So let's continue on. One of the things that we've already used in class is an angle bisector. So let's take a look at a problem that uses an angle bisector. So first of all, I mark my given. Angle G is congruent to angle I. So let's mark those the same. Then it tells me that FH bisects GFI. So this is the angle being bisected right here. So now I'm really on to step 2. I start marking the things that I know. So I know if an angle is bisected, it's split in half. So I know that this angle and this angle have to be congruent if they're bisected. I don't really know anything about this angle. I mean, it certainly looks like it, but it doesn't tell me that FH bisects GHI. So we're not going to mark any angles down here. We're not told that piece of information. The other thing I know is my reflexive side. HF is in both of them. So now be careful. This is not angle side angle. This is not 2 angles and their included side. That side would have to be FG. This is a side not in between my 2 angles. This is an example of angle, angle, side. Or you can call it side angle, angle. It doesn't really matter. But this is a side that isn't in between my 2 angles. That's why it's not written in between my 2 A's. So now I'm ready to write this up. So first of all, my statements, and then I have my reasons. So my first statement is everything I'm given. You're welcome to write that on 2 lines or just 1 line. I'll write it on 2 lines to show you what I mean. So that would be given. And then I could write the other part, FH bisects angle GFI, and that's also given. So if a student sets up their proof this way, they'll have one extra number than a student that put both of the givens in the first line and they wrote given. That's fine. So then what did I start marking? Well, because FH bisected my angle, I marked the 2 halves congruent. That's something I knew. So let's go ahead and write my 2 angles. I'm going to call it GFH on top. So GFH on top is congruent to. So on the bottom, I have to do IFH, IFH. And I did that because that's the definition of an angle bisector. We talked about this in class. It's splitting my angle in half. The next thing I marked was my reflexive side. I marked that because I knew it. So then FH is congruent to FH. And I don't flip-flop these. This is not a rotation. This is a reflection. So F goes to F and H goes to H. And so this is my reflexive property. And now I'm done. My triangle is congruent, and I'm going to write it just like it says in the proof statement. I'm not going to change anything around. Congruent to triangle IFH. And that was angle, angle, side. So what about a parallelogram or parallel lines? So this brings in the opportunity to use alternate interior angles, but you do have to be careful because sometimes it's only one pair, not both. So let's take a look at this. My first step is to mark what I'm given. So I'm given ST parallel to RU. So the top is parallel to the bottom. And then I'm also told that SR, this side, is parallel to this side, TU. Okay, great. That's all I'm told. That's all I'm going to mark. So now I start thinking of things that I know. Well, it jumps out at me that they have a shared side. So I do know that. And then now I have alternate interior angles I can mark. But be careful. If I look at the top and the bottom with this transversal, that gives me this angle as an alternate interior angle. In other words, I know that this little angle and this little angle are congruent by alternate interior angles. If I now look at the 2 sides being congruent, and I look at this transversal, it gives me the angle under the transversal and the angle above the transversal on the bottom. So that would be this angle and this angle. It's important you know which angle the sides are making congruent because sometimes you're only given one set of parallel sides. So you only have one set of congruent angles. So you have to be careful you know which one. So now I can see that this is an angle side angle problem and I'm ready to write it up. So my statements and my reasons. So my first statement is going to be my given. I'm going to write my given as 2 separate statements, mainly because I want to make a point about my alternate interior angles. Normally, just so you know, I always write the entire given as my first step. Today, I'm going to separate it because I want you to see, because the top and the bottom are parallel, that's how I knew that this angle, the single angle STR, angle STR, was congruent to this single angle on the bottom. And if I said STR, I have to say URT. And so those are congruent because alternate interior angles are congruent. So really important, the top and the bottom gave me my single arcs. So now my sides, SR being parallel to TU, that was part of my given, gave me my other set of angles. That gave me my angle UTR on top. so angle UTR, congruent to this angle SRT, over here towards the bottom. And that's also because alternate interior angles are congruent. So normally I would have put both of these in the first line. Then you could even write both sets of alternate interior angles. And so really you'd only be using 2 lines so far. Again, both are correct, but I really wanted to make a point about which lines are giving you which angles congruent. So then lastly, I haven't mentioned the fact that my RT is congruent, but be super, super careful. This is one of those where it rotates around the midpoint. This is a twist problem. RT is not congruent to RT. RT is congruent to TR. Those angles flip-flop in my 2 triangles. And so that's my reflexive property. And then finally, my 2 triangles are now congruent. Triangle SRT is now congruent to triangle UTR, and that is by angle side angle. So the problems on the back page are your homework. They're partially done. You need to finish marking them up and then write in what's missing. And then the problems at the bottom are isosceles triangle problems. So for example, let's take a look at number 7. I know that a triangle has to add up to 180 degrees. And I know in an isosceles triangle, my base angles are congruent. My base angles are across from my 2 congruent sides. So if this angle is 51, then this angle has to be the other base angle that's 51. That makes my angle that's x my vertex angle. So I know that it would be equal to 180 minus 51 minus 51. So 180 minus what? 102? I think that's 78, but check my math. 78 degrees is what x would be. So finish up this backside as part of your homework in our Schoology classroom. Thank you so very much.